Good afternoon, everyone. My name is Johan, and my teammate is Swapnil. He's a final year PhD student at New York University. Today we are proposing our challenge, which is fake news detection via cross-platform information tracing. And our team, me and Swapnil, we have been working on misinformation detection for many years, and this proposal is motivated by some of the problems or observations we have had in the last few years. So the first motivation is fake news is increasingly shared on multiple social media platforms. For example, in this graph is a study we did earlier, and the news URL we were tracking is from Daily Mail about COVID origin. And as you can see from the graph, this URL was first shared on Twitter and later on YouTube and other platforms. So many existing methods only focus on one platform, which miss the bigger picture and cannot measure the full scope and scale of those misinformation campaigns. So that's a cross-platform problem. The other problem is fake news. When it's shared on social media, is often shared by coordinated accounts. So again, in our previous study, we generated those type of network visualization to see how URLs are shared by different accounts. So some of the links are URLs and some nodes are accounts from different social media platforms. And often you can see a cluster of accounts sharing URLs. So there is actually rich information or intelligence we can extract from those network behaviors across platform. So our proposed challenge is giving cross-platform news sharing data. We want participants to design fake news detection models based on the context of the network behavior of news spreads, not the content of news. And I have some examples of the data set which will make it clear. And why is this proposal important? Why tracing it from social media context? Because the first part is crisis management, as we have seen in the past many years in the COVID and during natural disaster, people will share misinformation or rumor on social media and will spread from one platform to another. And the second part is basically for security or the stability of the society, because in places like United States, Brazil, there are cases of online misinformation leading to physical harm like riots. So it's also important to develop an early detection models based on social media signals. And third but not least, because using those network features, they are orthogonal to the language part. So the model should be robust to work with other languages. So we can also support regions with low resource languages or regions with multiple languages. And if we look at the existing solutions of misinformation detection on social media, none is perfect. There are several categories. So the first row are tools designed by different research labs like Botometer, Hoaxy, etc. So for those tools, they are publicly available, but they most of them focus on one platform like Twitter, and by that they can't really detect coordinated behavior. And the second row, you have Graphica, data miners. So those are private companies in the United States that help clients to detect misinformation attacked. And those companies, even though they claim they can detect coordinated behavior from multiple sources, but because they are behind the paywall, it is very hard to assess their true capability. And on the third row, there's information tracer, parrot, report. So those are some of the systems me and the Swapneo, our team, are developing. And basically, we collect data from different platforms, and we build metrics to detect coordinated behavior, and we make it available to researchers. And so far, we don't have a model to detect fake news, but that's a work in progress. But at least we are building like the foundation to facilitate the data collection. So in terms of the data set we want to prepare for this challenge, just to remind you, we want to build a supervised classifier to detect fake and non-fake news based on their social media data. So at first we need labels, and so we will focus on news URLs. And so luckily there are some resources that gave basically labels to what news are fake or not. So one of the resources is media bias fact check. So it gives news credibility rating to thousands of domains, news domain that cover many languages. And those ratings are given by professional fact checkers, and they are updated regularly. So basically we can select, based on the rating, fake news domains and credible domains, and for each domain we can get the URLs, which are articles shared recently, and then for each URL we can use APIs to collect data on Facebook, Twitter, YouTube, Reddit, Instagram, and each social media post will contain rich information like the text, username, timestamp, and so on. And to give you a concrete example, so here is a sample data set we can prepare for the challenge. So the URL we are interested in is a New York Times article about Trump and social media. And so what we can collect is on each platform, like Facebook, the Facebook post that mentions this URL, and you have different types of data like the text interaction, the username, timestamp. So participants can build different types of features by leveraging all those fields. So how do we want to evaluate the classifier? We actually have three criteria. The first one is just the standard accuracy of their model. So we'll prepare a held out data set that is only used for evaluation, so it's not available to participants. And for that one, we will calculate the F1 score, which is the standard score to test supervised classifier. And the second criteria is we will actually test if the model is robust against the data corruption. And the reasoning is because we're collecting data from different platforms with different APIs. Sometimes the API is not reliable, so sometimes you may not get all the data. So we want to make sure the model can take that into factor so it doesn't over-rely on any single source. So we will simulate that behavior by randomly blank out some data fields and use that corrupted data set to get another F1 score. And the third criteria is we will test if the model is again robust against the data manipulation. And this is also a very real concern because during the spread of fake news, those actors, they want to amplify their message so they can use bots or other software to increase the impression. So we also want to make sure the model doesn't solely rely on any one numerical value. So we will simulate a manipulated data set by randomly inflate some data fields and also calculate another F1 score. So the final metric will be the weighted average of those three scenarios. And here is our proposed three phases for the challenge. So phase one would be pre-competition. during the time we can collect the data set and market the challenge. And phase 2 will be the actual computation. And because we can prepare the data in JSON or CSV format, so we can host the whole computation on platform like Kaggle, and we can run it for like 3 months. And phase 3 will be post-computation when we announce the winners and we can deploy promising solutions. And finally, this is our feasibility study. I believe our proposal is feasible and impactful because it is technically feasible since we are already developing those data collection tools, and there are also other open source tools people can leverage to collect data from different social media platforms. And second, it is economically feasible because the cost of running the challenge is manageable, but the upside is huge if you can end up building some strong solutions and that will have big impact to the society. And finally, it is operationally feasible because our team, me, and some people, we have been mentoring students in the United States, college students on projects with a similar skill. So based on our experience, they should be able to deliver good results based on like a 3 months competition period. So with all that, yeah, thanks for listening.